Hello everyone, welcome to Numeric Learning. So today is day 16 of daily practice series wherein you will be taking your notebooks and doing problems with me. You will pause the video. So every day we will be spending around 20 minutes approximately, Monday to Friday or even Saturday, and we will be doing problems. And if you have any doubts, you will definitely, without a second thought, you will post it in the comments and I'll reply to them. Okay, so today we have got some three problems from the chapter Polynomials. Let's get started. The question is, if alpha and beta are the zeros of the quadratic polynomial, f of x is equal to ax square plus bx plus c. So what you are given is a standard quadratic polynomial. You have to evaluate two questions under it. You have to find the values of 1 by a alpha plus b plus 1 by a beta plus b, and the second one also, which is in terms of alpha, beta, a and b. Let's get started with the first one. Okay. So the very first question, let us assume that let alpha and beta are the zeros of the polynomial f of x equal to the standard quadratic polynomial ax square plus bx plus c. Okay, so the minute you have your quadratic polynomial, get the sum of the zeros alpha plus beta equal to minus b by a. Absolutely no change in it. And alpha beta product of the zeros is equal to c by a. Okay, now what you are asked is write the question as it is. 1 divided by a alpha plus b. I'm just writing the given question. This is the first question and then we will solve the second one. Okay, so using this quadratic polynomial, first of all we have found the sum of the zeros and then the product of the zeros, and now we are evaluating or simplifying this. So 1 by a alpha plus b plus 1 whole divided by a beta plus b is the question. The very first thing is take the LCM. The LCM will be the product of the two terms, that is a alpha plus b multiplied by a beta plus b. In the numerator, how will you write the LCM? So this term a alpha plus b multiplied by what will give you this entire product. So you have a beta plus b. This you have to multiply it with the numerator 1. So what will be the first term? It will be a beta plus b. Okay, and then the plus in between, and again a beta plus b is already there, so you have got a alpha plus b multiplied by 1. Okay, so you have a alpha plus b. Now let's combine. You can see you can take a common out from the first and the third term. Okay, so in the next step we will take a common out. You have alpha plus beta plus, what is b plus b? It is 2b. Okay, so plus 2b whole divided by, multiply each term. So a alpha into a beta. What is a alpha into a beta? It is, let me write it and then I will expand it. Okay, a alpha into a beta plus a alpha into b. Right, the first term with the first two terms, a alpha into b, and then plus b into a beta plus b into b, which is b square. Okay, so this is what you have multiplied your denominator term. So the numerator term remains as it is, a multiplied by alpha plus beta, because we know the sum of the zeros, plus 2b whole divided by, now let me multiply. So this will be a square alpha beta plus ab alpha plus ab beta plus b square. Right? Now again, I am not going to change the numerator, a multiplied by alpha plus beta plus 2b. In the denominator, the first term will be a square alpha beta. Again, I am not going to change it. In the second and the third term, I can take ab common out. So what you will be left with is alpha plus beta in the bracket. So ab common, you will have alpha plus beta plus b square. Now let us substitute. What is the sum of the zeros? Minus b by a, product is c by a. right? So instead of alpha plus beta, I'm going to substitute minus b by a. Instead of alpha beta, I'm going to write c by a. Let's do that. So here, a multiplied by alpha plus beta minus b by a plus 2b whole divided by a square multiplied by c by a plus ab multiplied by minus b by a plus b square. So a gets cancelled in the numerator. Again, the denominator a square and a here also. Whatever gets cancelled, you can do that. And what is left in the numerator is minus b plus 2b whole divided by, in the denominator you will have the first term is ac minus b square plus b square. This is what remains. Minus b square plus b square gets cancelled. What is 2b minus b? It is just b. b divided by, in the denominator you have ac. So this is your final answer. So in order to get each step has to be correct. Only then you will be getting your final answer as b by ac. Do pause the video and do try it and then verify your answer here. Be very, very careful in multiple places. In the very first thing is, when you're taking the LCM, this step has to be correct. And then when you're multiplying a alpha plus b multiplied by a beta plus b, right, individually, each term multiplied by every other term of the second expression. Be very, very careful. Do correctly each step. And even while cancelling, and when you are doing b plus b, it is 2b. Don't forget, b plus b is always 2b. Okay. And 2b minus b is b. So in these basic arithmetics, you have to be super careful. Now this is the first question. So we are done with the first question. So you have evaluated this expression. The answer is b by ac. Let's do the second one the same way. Okay, let me write it. The second question is beta divided by a alpha plus b plus alpha divided by a beta plus b. Again, you have to write, given alpha and beta are the zeros. Okay, so alpha and beta are the zeros of your f of x, which is given as ax square plus bx plus c. Okay, you know the sum of the zeros, alpha plus beta is equal to minus b by a and alpha beta equal to c by a. Every time, even if it is the second question, the steps do carry the marks. So please do not skip writing these steps. Okay, so you are given alpha and beta are the zeros of the given polynomial. Do mention it and also write the sum of the zeros and product of the zeros and then start solving it. So beta divided by a alpha plus b plus alpha divided by a beta plus b. Just the same as we did in the first question. The first step is to take the LCM. So the LCM is the product of 2, a alpha plus b multiplied by a beta plus b. So in the numerator, the first term would be beta is already there. Beta multiplied by a beta plus b plus alpha multiplied by a alpha plus b. Now let's multiply each term. So what you get here is a beta square plus b beta plus a alpha square plus alpha b. Okay, whole divided by a alpha into a beta plus a alpha into b plus b into a beta plus b into b is b square. Okay, so here what can we take common? What we can take is here, see, look here, in this two terms, you can take a common out. Okay, so a common, what will remain is alpha square plus beta square. And then in these two terms, right, b beta and b alpha, you can take b common out. So plus b, and then what remains is alpha plus beta, whole divided by, multiply each term. So you get a square alpha beta plus ab alpha plus ab beta plus b square. Now in the numerator, you should know an identity. It is nothing but alpha square plus beta square. See, let me write it here. Alpha plus beta the whole square is equal to, it's in the form of a plus b the whole square. It's equal to a square plus b square plus 2ab. This is something which we know. Now, what will be alpha square plus beta square? Just rearrange it. So, if you have alpha square plus beta square on one side, you have to take this 2 alpha beta to the other side. So, what will be the expression or the identity? Alpha square plus beta square is equal to alpha plus beta the whole square minus 2 alpha beta. So this is a very important identity which is derived from a plus b the whole square, and this particular derived identity, it's called as derived identity. The first one is a plus b the whole square, which we have been using it for many years now. Okay, it's a basic, common, frequently used algebraic identity. But the second one, this is called the derived identity. It's derived from the above one. Okay, so learn it throughout your class 10th. This is the identity which you'll be using frequently. So alpha square plus beta square equal to alpha plus beta the whole square minus 2 alpha beta. I'm going to replace it here. So what will the expression become? It will be alpha plus beta the whole square minus 2 alpha beta plus b into alpha plus beta whole divided by, in the denominator you have got a square alpha beta plus, again I can take ab common out, you have alpha plus beta plus b square. So now if you see, every term has either alpha beta, which is the product of the zero, or it has got the sum of the zeros. Okay, so now let me again continue writing. So instead of alpha plus beta, I am going to write it as minus b by a. Okay, so here you will write minus b by a the whole square minus 2 alpha beta is nothing but c by a, close the bracket, plus b multiplied by minus b by a whole divided by, in the denominator you have a square multiplied by alpha beta is c by a plus ab multiplied by minus b by a plus b square. Right? So now what expression do you have? A multiplied by b square by a square minus 2c by a minus b square by a whole divided by, you have in the denominator ac minus b square plus b square. So these two will get cancelled out, and a multiplied, the ones which are there in the square bracket, take a square as LCM. So you will have b square minus 2ac minus b square by a whole divided by ac. Right? Now again here 1a will get cancelled. So what remains is nothing but, again you can take the LCM as a. So b square minus 2ac minus b square whole divided by ac. Right, b square minus b square gets cancelled. So what you have is minus 2ac by a multiplied by 1 by ac. AC gets cancelled. So minus 2 by a remains. Okay, hence you have evaluated, hence evaluated. Okay, whatever, or you can just write answer. So this is your final answer. Please definitely do try it once and let me know if you're able to do these two questions. And if you have any doubts, please do post it in the comments. That's all for today. Let's continue the remaining questions of the polynomials in the next video tomorrow. Till then, happy learning. Thank you very much.